Thank you for joining us for today's webinar, Navigating Self-Leveler and Primer Options. There's some brief housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of our session, time permitting, or we'll answer them via email after. And you can always send questions to mapeidigital@mapei.com. Now, without further delays, I'd like to introduce today's speaker, Jeff Johnson. Jeff is the business manager for MAPEI's floor covering installation systems line. He brings to the industry more than 30 years' experience in the development and marketing of floor covering installation products. Practical experience in the construction industry and as a bench chemist gives Jeff an insightful perspective on surface preparation, moisture mitigation, and floor covering installation. Jeff, the floor is yours.
Thank you, Jen, and thank you everybody for attending. I hope this turns out to be something very informative for you. We have quite a bit to cover with regard to navigating the vast ocean of self-leveling underlayments and primers. There is quite a bit to talk about and quite a bit to learn, so if you'll join with me, we'll set sail and get started on learning about self-leveling underlayments and primers. To start with, hopefully what we're going to be learning about today are some learning objectives for you is why self-leveling compounds are used to support a floor covering installation. It may be a little obvious, but it's something we need to at least discuss. Understanding the various types of self-leveling underlayments that are available in the marketplace today, so that you understand a little bit about the chemistry, the differences between the different types of self-leveling underlayments. We'll do that. How to properly prepare a substrate to receive a self-leveling underlayment or topping. The function and use and proper selection of primers for self-leveling underlayments and toppings. I think again, there's more than just one primer available to the market today, and we need to make sure you understand why you'd want to select one versus the other. And lastly, to talk about some potential problems for self-leveling underlayment applications and how to avoid them. So those are hopefully the navigational points, if you will, for our journey across the ocean. And hopefully we get to answer all of these things throughout the course, throughout the presentation. So first and foremost, what is a self-leveling compound? Again, this is a little bit of background or basic information, but it is either a cement or gypsum-based powder. Then when mixed with water or polymer additive can create a flowable material like pancake batter, for lack of better description, that can be applied to an irregular substrate to create a level, defect-free surface, all of which is extremely important for the installation of all types of flooring, whether it be resilient, carpet, ceramic, or wood. The flatter the floor, the easier the installation and the better the end result's going to be. Typically, they're designed for high flow, long working times so that you can blend large areas together, and can be applied in ranges from a feather edge to 1/8 of an inch up to 2 inches, and sometimes 4 or 5 in a single application, depending upon whether or not you use an aggregate extension material or not. So a great solution for a wide variety of application, a wide variety of circumstances for subfloor preparation are what self-leveling underlayments are for. So first and foremost, why self-levelers? You may be wondering, why don't I just skim coat, etc.? And again, the reason is there is, in my opinion, Jeff's rules and experience in the marketplace and working with contractors in the market as well. There is no such thing as a flat floor. What you're seeing here on the screen is basically a laser topographical image of a concrete slab that's approximately 60 feet by 160 feet long. To me, this looks like the geographic map of the Raywall Wilderness I used to hike around as a kid up in Colorado, but this is a floor that somebody would have to install on. And as you can see, there are variations in this floor going as much as 2 1/4 of an inch of depth variation in terms of flatness. Now, certainly you can, this is a compressed image, and It's exaggerated in terms of what is going on with that floor, but that's a big difference. If you want to go ahead and install on top of that with the flooring or the building, you can do that, but that basically means that each piece almost has to be custom cut to fit vertical applications. The floor is not going to be smooth. You're going to feel variations underneath your foot. So this is why self-levelers exist, is to solve that problem, pour it across the floor, and allow for easier installation for flooring, as well as for an easier installation of the build-out materials. Again, keep in mind, if you have a floor that is super flat, everything becomes modularized. All your studs are the same size, all your modules that go in the cabinetry is going to fit perfectly, and so on and so forth, as opposed to having to shim things and adjust cuts and make everything fit to this variable floor. I'm sorry. But you might say, well, why can't I just skim coat that surface and be done with it? And I think it's very important that you understand that skim coating, a very common practice in subfloor preparation, creates a smooth floor, not necessarily a flat floor. There are people who are very good about skim coat applications, and they will go across the floor with a 10-foot straight edge and mark out the bird baths and the depressions on the floor, and then come back and do what they can with a hand trowel to fill those in. But at the end of the day, that's still not going to be a super flat level, laser level type of a surface to work with. It's still going to be undulating, if you use my words, versus self-leveling application that makes things level. Again, skim coats will make them smooth. Leveling materials will make them flat and level. So that's the main difference. Also must keep in mind that skim coating is a time-consuming process. If you are involved with the actual skim coating process, you know that you put one layer down, let it dry for a couple hours, come in and sand it, put the second layer down, wait that to cure another couple hours, and resand it. So there are a period of a day in terms of prepping a floor using a skim coating compound, not to mention a lot of dust generation, a lot of cleanup, and a lot of on your knees dragging skim coating material across the floor, compared to a leveling solution, which is a one-time application. Floor needs to be cleaned. Obviously, we'll talk more about this during this presentation, but pour it and place it, and it's finished and done, and you're installing flooring when it's ready to go. So I think levelers are really a much better product to use in terms of subfloor preparation going forward. Sorry, I can't remember where the buttons. Where are they used? Obviously, they're used in a wide variety of applications, preparing retail substrates prior to the final installation of flooring, educational environments, gym rooms and classrooms, apartments, townhomes, condos, building out floor insulation. This photograph that you're seeing on the screen here reminds me of a project that was done in the Vancouver area, in a tower project, a residential tower project, where the general contractor had contracted with a self-leveling underlayment contractor. To save some time in the installation process, he basically broom finished all the floors that were going up in concrete and had the leveler guy come by and finish the floors. So we wound up having something that was super smooth, made it easier for the build out, put the building, the walls in, doors in, cabinetry in without any kind of modifications. Saw some great benefits on doing that, as opposed to having the concrete person do the finishing of the floor. Commercial applications as well, such as airports and hospitals prior to floor covering installation. Again, all of these applications that I've mentioned to you have unique kind of requirements to them in terms of what the self-leveling underlayment needs to do and needs to stand up to the kind of traffic conditions that you're going to be exposed to. For example, back to that residential application, if you're doing a home where you're just walking around in your shoes and feet, you know, that leveler needs to make things flat, of course, but it doesn't need to really stand up to massive heavy rolling load conditions. Like the screen you see here in front of it is a hospital environment, And if you know anything about hospitals, they have extraordinarily heavy gurneys and hospital beds rolling around on top of those floors with very narrow wheels would put an awful lot of pressure on the substrate. So you need to make sure you're dealing with something that is capable of withstanding that kind of pressure. So having said that, those are some of the points that we need to be talking about in terms of navigating through all the choices for self-leveling underlayments. So what are the various types of self-leveling underlayments, and where are they used and what are the differences between them? Generally speaking, the world of self-leveling underlayment type products is generally broken into three different kinds of chemistries, if you will. All of them are designed to be mixed with water to create a finished product, but they work from different chemistry bases to start with. First one that we talk about is gypsum. This is a self-leveling underlayment that's very commonly used in multifamily housing because of it's got some unique fire retardant capabilities, and it's a relatively inexpensive product, can be mixed with sand on the job site. But one thing that's very important to talk about, it's the same kind of material that would be used as a plaster cast on your arm if you broke your arm. Very fast drying, very tough and durable. But one thing you must keep in mind with regard to gypsum underlayments is that they are extremely moisture sensitive. They cure by evaporation. The water in the mix has to evaporate in order for a gypsum underlayment to function. It's not something that the water is trapped like a cement-based material, which we'll talk about here in a second. It must totally evaporate. So that's important to know, because if you're applying a gypsum underlayment in a thin application, say 1/8 of an inch or 1/4 of an inch, you'll have a relatively quick drying process involved. If you're applying this at 2 inches thick, all that water has to evaporate, and that can extend the dry times of a gypsum underlayment quite a bit, up to the point where it could be weeks before it's completely dry, depending upon how thick it is. Calcium aluminate cement self-levelers are the bulk of the industry product. Perhaps more than half of it. The gypsum is about 40% of the market, and the calcium aluminate is in that also the 45 to 50% range. They cure by hydration, but in some respects are sensitive to high moisture conditions. And we at MAPEI do make some recommendations and provide some limitations on where a calcium aluminate cement-based leveler can be used. We don't want that used on high moisture content concrete slabs, for example, or anywhere that it's going to be exposed to direct water or moisture, because they can swell, they can soften, and they are not really designed for that kind of environment. And that's where the hydraulic cement materials are used. This is almost the same word as Portland cement. They actually cure by hydration and will actually get stronger on exposure to continued moisture exposure. So those are the three types of cement-based products or chemistries, if you will, to make a self-leveling underlayment. In the MAPEI product portfolio, we have products in all of those. When we talk about gypsum levelers, we have two in the product portfolio, Planetex SL and Planetex SLF. Planetex SL is a unmodified, if you will, high flow gypsum self-leveling underlayment, extremely smooth and fluid to use, recommended for use above grade applications on a wide variety of substrates. You can add sand to this to extend it, to increase its performance characteristics, reduce the overall cost with it. We recommend adding MAPEI sand fine to this. A 40-pound bag of MAPEI sand fine mixes perfectly with 2 50-pound bags of Planetex SL. Again, same great flow properties, easy finishing, and a great product for what that's for its use. Planetex SLF is based on the same chemistry, again gypsum, but a fiber reinforced material. And the fibers in that material, if you look at them, are very long, relatively speaking, maybe 1/4 of an inch to 3/8 of an inch in length, blended through that formulation, which makes this an extremely durable, flexural, resistant type self-leveling underlayment. Again, perfectly designed for use on wood substrates, above grade cement-based substrates as well. So those are our two gypsum-based products. Again, as I mentioned before, in our calcium aluminate cement-based levelers, we have the majority of our product portfolio, and we have quite a few of them here. We're looking at almost, I might get my quick count, 10 self-leveling formulations in the calcium aluminate cement leveler base. Why do we have so many of them? Because there are a wide variety of uses, demands, and overall requirements for these products to work. We begin with NovaPlan SP, which is our standard performance self-leveling underlayment. This is a great product for base grade installation leveling applications, compliant with ASTM F710 requirements of a 3,000 or greater PSI, a great price point, a great flow properties, a great basic entry-level self-leveling underlayment. We follow that with NovaPlan 2 Plus, which is a little bit faster setting, a little bit more robust. NovaPlan Easy Plus is a shrinkage compensated leveler that doesn't require shot blasting or profiling. NovaPlan DPL is the deep pore leveler, which is a product we just recently introduced that can go up to 4 inches in a single application, which is incredible. But there are people that have had needs to put self-leveling down up to 2 to 3 inches or 4 inches at a single time. There are issues with other formulations to be able to do that. This is specifically designed for deep pore applications. NovaPlan HFL is a new one we've just introduced to the market. A high flow self-leveling compound. This product mixes up and flows onto the floor like a thick chocolate milk kind of a application. Extremely fluid, very easy to place, flows like water, and it's very easy to place is really what the whole deal is here. Again, while we're on the page here, you'll notice there's a distinction between NovaPlan and UltraPlan. I want to make sure you're aware of the differences between those two names. NovaPlan products typically are slower setting, more economical choices for self-leveling underlayments. UltraPlan families are typically engineered faster, higher performance materials. So when you're working on how to navigate through the vast ocean of self-leveling underlayments, do remember that NovaPlans are your entry-level base grade products, a little bit slower setting, perhaps an easier journey. And UltraPlan product family is something that gets you there quicker and faster and a little bit higher performance. The UltraPlan family starts with UltraPlan 1 Plus. This is a go-to product for many people, contractors in the marketplace. High performance, fast set, and a track record that's unbeatable, really, in terms of self-leveling underlayments. UltraPlan Easy, another product that is designed to be shrinkage compensated, so you don't need to surface profile the concrete prior to the application of it. UltraPlan M20, a very high compression strength self-leveling underlayment. This one can work as a warehouse floor or final floor if you so desired, with a sealer or finish on top of it. UltraPlan LSC, similar to NovaPlan HFL, but faster setting and higher compression strength. And UltraPlan Light, our lightweight self-leveling underlayment, which has about half the density of all the rest of these levelers we've talked about. So that's a mouthful of levelers, and that's the big Atlantic Ocean of products that we have to navigate and understand why you want to pick one over the other, which we will spend some time talking about here in a minute. The second to last category we have are hydraulic cement levelers, and that would be our UltraPlan Extreme 2. This is a weather-resistant, high compression strength self-leveling underlayment that you can use in an uncontrolled environment, something that doesn't have the doors and windows installed. The HVA systems are not operating. It's a very robust leveler that we recommend for use in what we call go early systems. Go early would be an application, as I mentioned before, early construction. The floor hasn't been fitted out. The plumbing and air conditioning have not been installed in the building. This is the only one we recommend for that kind of an application. You can install it 6 hours later. It could be rained on and nothing's going to happen. It could be flooded over by sprinkler line breakouts or whatever you want to call it. It's unimpacted. So all that stuff is the reason why UltraPlan Extreme 2 exists. The last one we have in a portfolio is Polyplan RSL. This is a kind of a unique product in the fact that it's not mixed with water. We provide a latex additive to it. The unique characteristic, several of the unique characteristics of Polyplan RSL are that it can be used directly on top of non-porous substrates without the need of a primer. So if you are a contractor on the webinar here today and are looking for primerless solutions, because primers take time to dry, they're an additional step, Polyplan RSL is the way to go. They're extremely fast. This one can, once applied, is ready for sheet vinyl installation at 3 hours after application. You can see that in this photograph, you can actually watch this one cure in front of your eyes. It happens about an hour and 15 minutes after application. The whole thing starts to gel over and harden up, and 2 hours later, it's rock solid and ready to go. The whole goal on this one was for application directly over epoxy moisture control membranes without the need for an additional primer. So that is the last one we've got in terms of our product portfolio. So what are the differences between all of those? And what we typically look for and observe, and some of the choices that you would want to make when you're selecting one leveler over another, are flow properties, dry time, compression strength, and depth of fill. There are a few other measurements that we do put on our technical data sheets, but I think these are the main four that we want to look at and are really mostly important to you as the contractor or the installer. Let's start with flow properties. And flow is a very interesting measurement. Again, not something that we typically publish on our technical data sheets, but something you need to be aware of. When we design and develop self-leveling underlayments, part of the design matrix for R&D people to work with is certain numbers of flow properties. The flow property test in the lab begins with a small cup of mixed material, which is placed on a glass sheet. The cup is pulled out. The cup doesn't have a bottom to it, and when that cup is lifted up, all that leveler flows out, and we measure how far it flows across the glass sheet. So that becomes a flow measurement. Not only do we measure how far it goes apart, but we also measure how quickly it flows. So this chart, excuse me, this slide that we're going to show you here kind of gives you a visual representation of four of our products' flow properties, basically. You're looking at NovaPlan HFL, UltraPlan 1 Plus, NovaPlan 2 Plus, and UltraPlan LSC. When I click the button for start, you're going to get a visual representation of how these things work. Hopefully that worked. Hold on. Here we go. So as you can see, the NovaPlan HFL spreads quite rapidly to a much larger film versus UltraPlan 1 Plus versus NovaPlan 2 Plus versus UltraPlan LSC. You get a little bit of a visual representation. HFL, as I mentioned before, the new one we've just added, is a very fast flowing fluid material and spreads quite a distance. If you don't need the speed and you're worried about placement and need to build thickness up, you might want to select NovaPlan 2 Plus instead, since it's a little bit thicker, a little bit more difficult to spread versus UltraPlan 1 Plus. UltraPlan LSC has a very similar flow property, flow number to HFL, but it takes a little bit longer to get to it. So HFL, very fast, very speed. Oops. Another important aspect of our self-leveling underlayments is the wait time before floor covering installation. And typically we give you two numbers. One is for the installation of ceramic tile or non-moisture sensitive flooring. And another one is the time required for moisture sensitive flooring. The reason why we have those two, a ceramic tile installation typically is using a mortar bed, and it really doesn't matter whether there's any residual moisture left in the self-leveling underlayment. It's not going to affect it so much, where that residual moisture would create a problem for a moisture sensitive floor covering or a water-based adhesive as well. So that's why we have those two numbers in place. So here you're looking at a chart that shows you the dry times or the suitability times for many of our levelers for those two different types of floor covering. What I do want to mention is I started at the very beginning about the discussion about gypsum underlayments. The Planetex SL and the Planetex SLF are kind of a vague number there, and that's on purpose because that really depends upon how thick you apply it. If you do apply it at a 2-inch thickness, that dry time is going to be in the order of 1 week to 2 weeks before you can get on it with any kind of moisture sensitive flooring. You must let that product dry before you get to it. Again, if I'm down to a 1/4 of an inch or an 1/8 of an inch application, that's a whole different number. Our technical data sheets for those two products say that they are dry when you put a Delmhorst particular meter on top of that, and it's less than 5% residual moisture, then you can go ahead and install moisture sensitive floor covering on top of it. The rest of them you can see, the Nova plans, as you compare them against the Ultra plans, do have a little bit more extended dry times. So if you're not in a big hurry, the Nova plans are a great solution. If you are in a hurry, then you can look at the Ultra plan family or even the Polyplan RSL product as a solution. Why do the Nova Plan DFL and HFL and Ultra Plan Light have such extended dry times for moisture floor covering? That's because they have an awful lot of water in their formulations that does take a little bit longer to hydrate. And again, NovaPlan DPL is designed for use up to a 4-inch application. That's a lot of material that has to hydrate. NovaPlan HFL, again, has a high water add, so there's a lot of moisture that has to be hydrated in order to make it suitable for high moisture, for high sensitive flooring. And UltraPlan Light is another one that has an awful lot of water in the ratio, which all has to react and some evaporation before you can get installation of moisture sensitive flooring on top of it. So again, when you're navigating selections for levelers, many things you have to look at are how much time do I have to wait, or am I in a big hurry or not? What is the finished flooring that I'm going to be installing? Is it moisture sensitive like wood and carpet and resilient, or is it ceramic tile? Those kind of things will help you make that decision. Compression strength is another thing. What is the type of traffic conditions and heavy rolling loads that I'm going to be exposing the floor to? And again, if you take a look at the number that's provided by the ASTM F710 requirement, which is typically 3,000 PSI, virtually all of our levelers are above that number. But if you need something to handle heavy rolling loads in a hospital environment, perhaps even in a casino or rolling money across the floor in heavy carts, or a warehouse floor that you're running forklifts and hand trucks across, you would want to select ones that are higher compression strengths. So surprisingly, and you may not think about this, our Planetex family has some of the highest compression strengths out of the whole family. So don't exclude the thought of using a gypsum underlayment on above grade installations just because they're gypsum. They are high performance products. They got great flexural strength and they're extremely high compression strength and very easy placement products to deal with. Keep in mind that they do have that time constraint for dry time, so you have to dial that into your equation. Obviously, the UltraPlan families are a little bit higher compression strengths than the NovaPlan families. We're getting a little bit fuzzy with UltraPlan. NovaPlan HFL is a high compression strength product. But again, these are some of the attributes that you would consider in terms of your navigating which type of leveler to pick. Depth of fill is another important aspect as well. And again, single lift application ranges for our levelers. And again, this number is given to you as if you were going to apply it neat. In other words, you're not mixing it with any aggregate. It's just the product by itself. And we typically do limit the application of these products to certain depth of fill for a reason. Most of which has got to do with the heat generation during the curing process. Many of these levelers, all of these cement-based levelers do generate heat as they cure. The thicker you apply it, the more heat is generated, and we're trying to avoid having that heat create a situation where the leveler expands too much and blows off the floor. But here you'll see the depth of fill for these levelers in their neat application, all of which can be extended with aggregate up to 5 inches of fill based on how much aggregate and the size of aggregate that you're using with the exception of Ultraplan Extreme 2, Polyplan RSL, and NovaPlan DPL. All right, so preparing the job site is important for all of these levelers to be done with. If you're dealing with concrete, you must check for moisture content using the ASTM 2170, ASTM 1869 number. This is one of your navigational points, if you will, for determining which leveler I can use. Most of our levelers are set up for a limit of 5 pounds and 80% RH. NovaPlan HFL is a new one introduced at 8 pounds and 90%. Ultraplan Extreme 2 has no limits. So you got to make sure you're doing your proper testing for that. Check for structural integrity. If the floor has additional flex beyond L/360, you're pretty much going to limit yourself to looking at Planitex SLF that has the ability to handle that flex. But you want to make sure your substrate is strong enough to support what you're dealing with. Check for the presence of curing compounds, sealings, and other contaminants. This is a big problem for self-leveling underlayments. Those curing compounds must be removed, and you're dealing with a pure surface to stick to. Primers and levelers bond very well to curing compounds and sealers and other contaminants. The contaminants do not stick very well to the concrete. And so if you're trying to avoid hollow spots and delamination, all that stuff's got to be taken away. All the voids, cracks, and gaps and holes in the concrete have got to be filled in to keep the liquid leveler from flowing into unwanted areas. My personal experience, I've tried to level a crack on a floor that had a crack in it, and the leveler keeps going and going and going and going and going in that crack. That's a bad idea. You're wasting material, and you're going to wind up with a problem in that spot. Fill those up with the appropriate material, and we'll talk about that as well. Check for surface profile. Many of our levelers require, and primers require, some sort of profile for functionality. Some do not. Any of our levelers that have the word easy on the name do not require a surface profile, but everything else typically does require some sort of preparation to a CSP of 2 or 3. And the building must be enclosed with an HVA system, operational, running at occupancy level. So all this stuff is important. The types of substrates we deal with are concrete, and I refer you to the ASTM F710 standard. A lot of that information is there for how that concrete needs to be prepared and set up. If you don't have this standard, I highly recommend you get to the ASTM website and find them. For wood, there is a standard practice for panel type underlayments to receive resilient flooring. That's another great one to have that talks about the nature of the type of the wood that's being used, how it's supposed to go together, what kind of flexural strength that needs to be involved, as well as a standard for gypsum. So all of these things are very good to have on your reference file of information. If you don't have them, I would highly recommend you get them. There is, believe it or not, a standard for ASTM for the standard practice for the installation of self-leveling underlayments and the preparation of the surface to receive resilient flooring. Again, another good standard to have in your box of resources when you're dealing with how to prepare them. Again, moisture testing is typically all done by these tests. I don't think we need to spend much time talking about them here, other than to say that these tests are worthless unless you properly prepare them and that the HVA systems are operational and you're doing them according to the test method requirements. If you're trying to do an RH probe test and the walls are not up and the windows are not up, you're wasting your time. And the same thing is true for the calcium chloride test. These tests are only valid if the building is enclosed and the air conditioning is running. So do keep that in mind. But that is a navigation point for which leveler to use when you get that information. If those results come back and you have a high moisture reading beyond what the limits of the leveler can take, then you've got to consider the installation of a moisture mitigation system. That's for another presentation as well. But generally speaking, those are a couple choices: a 2-component 100% solid epoxy system. Our plan is still VS and VS Fast, which are ASTM F3010 compliant. If it's not super wet, you can pretty much use some of our 1-component water-based polymer solutions for mid-range moisture conditions like Planet Seal MSP. And some conditions you can also use our 1-component polyurethane system, Planet Seal PMB as well. So those are the solutions for getting that kind of done. Creating the profile is extremely important, probably more so not just necessarily for creating texture, but to get the floor clean. Again, many failures that we deal with on a self-leveling underlayment application are due to improper subfloor preparation. A sealer was left on, there was oil residue left on the floor, taco sauce in a corner that spilled. These kinds of things are going to create problems for the bond of the primer. And when that is a problem, then we have a failure of mine. So there are a variety of methods for creating that profile. Our International Concrete Restoration Institute has got some great recommendations. If you look for that chart and that information for self-leveling, we're trying to get to a CSP of 3 or 4 for most of that. Look at our technical data sheets. I think for the most part, we're looking at a CSP or 2 or 3. All of which can be achieved by grinding, shot blasting, sandblasting, and certification. A little bit of a myth correction, if you will, for MAPEI. Sometimes I've been told that people believe that our only solution for preparation of a concrete slab is shot blasting. That is not true. We recommend and endorse grinding, shot blasting, sanding, whatever, as long as it achieves that CSP requirement that we're requesting and that it's properly cleaned and there's no dust residue left on the floor, we're perfectly good with that. So do keep that in mind, that there's a variety of different methods for preparing a floor to receive a self-leveling underlayment. At the end of the day, your concrete needs to be clean, pristine, and looking like, I don't know how to explain it other than it looks like 100 grit, 120 grit, or 80 grit sandpaper on the floor. Some clean texture for which everything needs to bond to. Cracks also need to be repaired, as I mentioned before, purely because of keeping the leveler from flowing through that concrete crack into the areas below. That's not a good situation. And sometimes these cracks are structural and need to be addressed as well. So whenever you get on a concrete slab that has cracks throughout it, a structural engineer should be involved to take a look at that and see whether or not they are active cracks that need to be dealt with in a unique way, or if they're just structural cracks that can be fixed with normal application, normal remedies. If it's a non-structural type of repair, you can go into that with a flexible sealant. Semi-rigid, we have things like Planabond JF to fix some of these products. Planabond EBA with sand can be used for this as well. Sometimes they can even be filled with a patching compound prior to the application of a leveler if they're non-structural type products. If they're structural and are moving joints, then we need to figure that out a little bit differently. Gravity fed epoxy systems, point injection epoxy, all this kind of stuff to lock that together to make that a suitable substrate for bonding a leveler. Again, these things need to be reviewed and dealt with by a structural engineer to make sure that that is the right solution for what you're dealing with. So, having said all that, how do you navigate through the choices of self-leveling underlayments for your particular project? Just like a buoy is a navigation point for your sail on the ocean, what are some of the buoys that you have for self-leveling selection? As I mentioned before previously, if your project is not fast tracked and you have time and you're working on a budget, to be honest with you, then you could look at our Nova Plan family or our Planitex family, which is a little bit slower setting, a little bit more generous and forgiving to the wallet, if you will, as opposed to something else. If your project requires a rapid turnaround, then you're looking at our Ultra Plan family. If your project has weight load issues, if you're dealing with a cantilevered concrete slab or an old antique concrete slab that's not capable of taking the full load of a 2-inch normal self-leveling application, then you would take a look at UltraPlan Light for that application. If your project is going to wind up being a warehouse floor straight with no other floor covering on top of it, our only solution for that is UltraPlan M20 at this point. If your project is installed without HVAC system controls, or the windows aren't in, the doors aren't in, and it's a wide open building, even if it's going to be a curtain wall type construction and you need to get the slab straightened out and the glass is not up yet, your only solution for that is UltraPlan Extreme 2. If your project is wood-based, has flexural issues, if you're dealing with an existing multifamily housing project with a 2-inch pour gypcrete that's cracked up and looks like the surface of Mars, Planitex SLF is the perfect solution for that. If your project is over an epoxy membrane and you don't have time for the primers to dry, then Polyplan RSL is your solution. If your project requires a deep fill application, then NovaPlan DPL is the way to go. If your project is exposed to heavy rolling loads, you're looking for products that have a high compression strength. So any one of those products will work for that. The project has to be done in 3 hours or less, which if you're thinking about an operating room rehab, for example, in a hospital environment that requires moisture mitigation, and they need to get that operating room back into service because that's a big money maker for the hospital, Polyplan RSL is a way to go for that as well. Okay, so those are some of the navigational points for self-leveling underlayment selection. Having said all that, there are a few other points that are in a very important aspect of self-levelers that we need to address, because you can't really say self-leveling underlayment application without involving a primer. These two things go hand in hand, like a ham and cheese sandwich. You've got to have both of these things involved. So we've got to deal with the primer choices as well, and there are quite a few of those to deal with, and in their own sea, if you will, of selections and different types of materials to go on as well. So what is the function of a primer? First and foremost, to create a uniform substrate for which the leveler to bond to. Yes, we have gone through the process of making sure that concrete is smooth, clean, free of any sealers and debris, but we still need to make sure that that is consistent throughout. So the only way to do that is to apply a primer of one form or another to make sure that's the case. The other aspect of it is that it seals off that substrate to reduce off-gassing or pinholes from forming. What do I mean by that is if you have an open concrete slab or even a piece of plywood that you're working with as a substrate and pour a liquid material on top of it, that liquid's going to go into any kind of pores and openings in that substrate. And when it does that, the air that was in that pore is going to come up through that leveler and create pinholes and eruptions, volcanoes, if you will, on the surface of that leveler. And once it's cured, that's not really what you want to have happen. You want to have a nice smooth surface on which to install on, rather than have to come back and resand and skim coat over the holes that you've created by not dealing with sealing off the substrate. So that's a very important aspect of it. In some respects, with certain primers we have, it consolidates a weakened concrete. Not really a very common process or something to deal with unless you're dealing with like a lightweight concrete that has some friability issues, but we have primers for that. And another part of it, which is important, is it creates texture for enhanced mechanical bond. We do have some primers in our product portfolio, which we'll talk about here in a minute, that eliminate the need for profiling. Basically, we have a couple of solutions that make all of our products easy installations by creating profile by just rolling them on the floor and letting it cure up, and it creates the kind of profile necessary for that leveler application. A little bit about the chemistry of them. Many of our primers, the bulk of the business we deal with today, are water-based acrylics for porous and non-porous substrates. They're smooth, easy to apply, paint-like in nature. Then we have water-based textured materials that have a built-in aggregate to them, creating that texture. Again, these are great solutions for today's environment where you can't shot blast or create dust and debris in the shot blasting and scarification process. Make sure the floor is clean and apply a textured acrylic, and you have your CSP, if you will. There are epoxy-based primers that are available for high performance applications. For example, if you're trying to create a warehouse floor that's going to be exposed to an awful lot of heavy traffic, epoxy systems using sand broadcasts are the perfect choice for that. Plus, we also have some polyurethane materials as well, also using a sand broadcast for moisture control and bonding solutions as well. So there's a variety of different options for primer bases. And so how do you navigate through all that? A little bit more about the details of them. MAPEI's offering for acrylic primers, our Primer L. This is a workhorse for the MAPEI primer solution designed for use on porous concrete as well as gypsum materials. It is diluted 3-to-1 with water, so you've got a great value there. It does a great job. Does require a couple coats typically for doing that. Can be applied to porous concrete using a roller system. But one thing I want to mention to you, if you are applying Primer L to a gypsum substrate, it's very important that you use a stiff bristled broom for that application. Do not roll coat it. That stiff bristled broom does a great job, and the only job is to break up the latency of the gypsum surface and get that Primer L into that and blend into the surface to make sure you have a proper bond. Roll coating on top of a gypsum underlayment is a very dangerous aspect because it doesn't really get a chance to blend in with a dust, if you will, on the surface of a gypsum underlayment and can come off very easily. Just a sideline about Primer L. Primer T is another workhorse for us. If you're not familiar with it at this time, we had a color change on Primer T a while back. It's this nice, lovely magenta color you see on the side. A great way for you to determine whether the proper application is in place. So make sure you apply it properly. One thing about primers is more is not necessarily a good solution when it comes to primer application. Thin is really how you win with most primer applications. Again, you want to get them thin to do their job and as well as to allow them to dry quickly. If you're going to install them thicker and think that more is better, it's going to take a lot longer to dry. You may wind up having a softer area underneath the cured film on the top. Those kind of things can create some delamination problems for you downstream. So thin to win for most primer applications. The other acrylic primer we have in the box is PlanetSeal MSP. This is a unique primer in the fact that it is somewhat of a moisture barrier reducer and primer for self-leveling underlayments. So if you're dealing with a concrete slab that has a moisture vapor emission rate up to 15 pounds and 99% RH, you can go to PlanetSeal MSP prior to the application of any leveler we have in the box. Textured primers, again, what we're dealing with here is a primer solution that provides the texture that you need for performance installations of self-leveling underlayments. Primer X is a new one we've introduced to the offering. It's a fast drying texture primer specifically designed for the application over epoxy membranes, but that's not its only use for that as well. It is textured, dries within an hour after application, can be used over any non-porous substrate, particularly epoxy materials, can work on high polished concrete slabs as well as non-porous concrete as well. So it's a very robust solution, very fast drying, works extremely well for preparing a concrete slab to receive self-leveling underlayments. Another one in our offering, which has been around for quite a while, is Eco Prim Grip. This is a great product for use over existing ceramic tile applications, other non-porous concrete applications, over old adhesive residues as well. The main difference between the two is Eco Prim Grip does require a little bit longer dry time than Primer X. Our epoxy primers, we have a variety of these as well, and these, again, are not your everyday solutions, but when you're dealing with a high performance leveler application, that's when you need to get to these. Primer E is a 2-part low viscosity epoxy primer, mix part A and part B, get it on the floor. If you have a metal deck, if you're dealing with an existing epoxy surface, these are great. This is a great primer to use. You apply it on the floor, sand broadcast across the surface with MAPEI sand coarse or MAPEI sand fine, get sand to rejection, remove the residual sand, and then apply your leveler for higher performance applications. Primer CE is a low viscosity epoxy that helps consolidate a friable concrete slab prior to the application of virtually anything. Primer WE is a water-based epoxy, and this one has a great claim to fame is that it can go over old adhesive residue without any problems, creates a very sticky primer base for all levelers, so works over metal surfaces as well. So this is one of these, if you're dealing with a problematic job site that's got all sorts of things going on with it, Primer WE is a great solution for that. A couple other choices, a Planet Bond EBA and Planet Primer SN. These products are specifically designed for the use underneath many of our topping compounds, which I've not spent much time talking about. That's another subject completely to talk about as well, and I'd ask you to get to our CRS folks for installation information on toppings. But Planet Bond EBA and Primer SN are 2 high body, high modulus epoxy materials, which also get sand and broadcast in them and are the only solution we have for priming underneath topping compounds, so something to think about. And the last one we have in our offering is Planet Seal PMB, which is a 1-component moisture curing polyurethane applied in a double coat application with sand broadcast. This also provides moisture control up to 25 pounds on 100%, as well as providing a very strong bond for all those applications we've mentioned before. So how do you navigate through all of that? If your substrate is a gypsum underlayment, you're really dealing with choices of primer L or T. If your substrate is wood-based, it's primer L or T, porous as well. If your substrate is porous concrete, you see the choices there of L, T, or X. If your substrate is non-porous, we get a little bit more detailed, but we drop off L, primer X, primer T, primer WE, primer E with sand. If your substrate is an epoxy membrane, if you already got something like Planet Seal VS down, or if you're dealing with any other kind of an epoxy coating, Primer X is a great solution for that. Or we go back to Primer E with sand to work with that. If you can't profile a substrate, shot blasting is not allowed. You don't either have the power or you're available to you, or you're dealing with silica exposure issues, then Primer X or Eco Prim Grip is available as well. Keep in mind the difference between the two of those is speed of dry. If your application is high performance, if you're creating something that's going to be a warehouse floor, if you're going to deal with something that's got heavy traffic, then I would look into the Primer E, Planet Seal PMB, Planet Bond EBA, Primer SN, all of which need to have a sand broadcast system. The difference between this, folks, just to give you an idea of the numbers, if you're looking at a water-based solution, even our Primer X or Eco Prim Grip, Primer T versus the bond shear strengths of an epoxy solution, typically a water-based solution or even our Primer X gives you slant shear values in excess of 450 to 500, 600 PSI kind of numbers. An epoxy solution, even the polyurethane solution, will give you anything in the order of 2,000 to 4,000 PSI compression slant shear numbers, almost 10 times the strength. So that's why we're looking for why you would want to use one of these high performance primer solutions is if you really need something to stay stuck and it's going to be exposed to an awful lot of traffic or polishing conditions, that needs to be where you're thinking about using these kinds of primers. If your substrate is existing ceramic tile, I'd look for Epoxy Eco Prim Grip. If your substrate has high moisture and you want to do one-step priming, Planaseal MSP, Planaseal PMB with sand broadcast. If your old substrate has old adhesive residue, primer WE or Eco Prim Grip. If your concrete is brittle and friable, like a lightweight concrete that doesn't have enough integrity for a leveler application, primer CE first, followed by primer E and sand. If your substrate is an existing resilient flooring, look for primer T and X and T. Mixing equipment, again, for levelers, I kind of come back around to this, is pretty simple. You can mix it in a pail depending upon how big of an application you're going to deal with. If you're doing a small laundry room, for example, a 5-gallon pail is probably adequate. If you're dealing with things that are up 500 square feet to 500 to 1,000 square feet, barrel mixing is a great way to go. If you're dealing with areas that are 5,000 square feet or above, pumping equipment is really kind of the way to work with. MAPEI does have some equipment available to help with this process. We have a self-leveling mixing kit, which includes everything you see there on the screen: a gauge rake, mixing pitcher, spike shoes and smoother, and a gauge rake. We have a cart that carries that around and makes it very easy to place. We have a mixing barrel, and we also have a 2-inch spike roller available. Placing a self-leveling underlayment once the product is mixed is a little bit of a work of art, and there are people that know how to do this extremely well. You typically spread that pour out on the floor using a gauge rake that's set to the thickness that you need to get to, blending the pores together using a spike roller, and then finishing the surface to kind of break the surface tension of that leveler using the smoother to make a nice smooth surface. One thing that's very important about a leveling project is you need to get organized. I don't really want to call this a Chinese fire drill, but it is a little bit of organized chaos when you're working on large installations. If you're dealing with a small 50 square foot installation, this is not that big of a deal. You can mix a couple bags at a time and pour it on the floor and get going. But if you're dealing with a large area, you really need to spend some time thinking about how to set up a mixing station and getting that product on the floor in a consistent pour. Because once you get started, you can't really stop once you get started. It's kind of like pouring concrete in the Great Hoover Dam. You just keep pouring and pouring and pouring until the project is finished. As a consequence, you need to do some significant thought process on how to get set up to do that. And that really requires you to think about where you want to put the mixing station, getting all the leveler bags staged and many of them cut and ready to be opened up, close to a water supply. The water needs to be the right temperature and plenty of availability, and having all of that set up so that you can mix consistently, mix easily, and then get the material placed and move to the right job site where you need to go. So spend some time thinking about how that gets organized before you jump into a major leveler application. Underlayment failures. Why do things go wrong? And again, I go back to reminding you of all the things we've talked about in terms of subfloor preparation. If you don't pay attention to that, these are the kind of things that can happen that will cause a failure. Improper subfloor preparation. A primer was not used. The wrong primer was selected. The primer was over diluted, for example. Primer didn't get enough time to dry. The substrate wasn't profiled. The contaminants were removed. Those are all going to create a bond breaker for this very expensive material that you just put on the floor to make sure everything's nice and smooth. Really trying to avoid you having to do this twice. Make sure all those selections and preparation are done properly. Excessive moisture rates and emission rates are a problem. If you don't do the moisture testing, not only will that have a problem with the leveler that you install, it's going to have some impact on the adhesives and the flooring that you've installed on top of it. So it's extremely important, even in today's advent of high moisture resistant adhesives, you want to make sure you understand the moisture conditions of your concrete slab. If you don't want to waste your time worrying about that, install a moisture barrier, and then you'll never have to deal with it again. Again, high pHs will degrade the primer that you're using. High pHs in the area of 12 above, a pH of 12 can cause these primers to disintegrate, if you will. That's not a good situation, and also indicative of a high moisture condition. Osmotic blistering can cause delamination. That's a whole nother seminar in itself to talk about causes and cures for osmotic blistering, but we've seen that happen as well. Improper mixing, one of the most important aspects of a self-leveler application, which I really need to spend some more time talking about, is mixing it properly. Again, read the technical data sheet for the leveler that you're choosing and stay within the range of the water ratio that's provided. Do not decide on your own, well, that's too thick, I'm going to add another quart of water to thin it down. That's going to cause you some problems. Those problems will result in what you're seeing on the screen. You can also see separation of the fillers. You're going to wind up with very thin stuff on the top and sandy stuff on the bottom. All of that's a definite no-no for self-leveling under application. That will be a problem. So do make sure you use the right water ratio, use the right water temperature, and make sure you mix it for the right amount of time. Again, all of our technical data sheets will tell you how long they have to be mixed. That's there for a reason. All the good stuff takes some time to blend out. And if you mix it too short, you'll wind up with bumps in the surface, flecks of things that you don't want to see. So do make sure you mix it properly. Lack of protection is another reason for causes for failures. If you put this in direct sunlight without protection, you can surface flash cure at the top of the leveler and you wind up with an alligator looking skin. It'll crack on you. Excess wind or air conditioning movement. I've seen an installation that was poured right underneath an air conditioning vent, and you could kind of see the ripples of that air blowing that material out, all of which were something that had to come back and be resanded and abraded, an additional waste of time by doing that. Freezing conditions are also very destructive for a self-leveler underlayment. So, for example, if you're installing it at the lower end of the application spectra, which in many cases is 45 degrees, 50 degrees to 90 degrees Fahrenheit, if you're at that 45 range, pour a leveler in the evening, the building is not under air condition, it's not heated, and everything freezes. The water that's remaining in that leveler will crystallize and blow the thing off the floor. And obviously, do try to keep Gracie from walking on that, all that work that you've done there as well. So, in summary, there's a lot of things we've talked about in terms of navigating this vast ocean of selections for levelers, but what they do is they're typically a very fast and consistent method for creating a flat surface over large surface areas. They're uniform substrates for virtually all floor covering types, carpet resilient wood, laminate, you name it. Means to correct surface defects up to 2 inches, in many cases 4 inches in a single lift or more with aggregate extension. The keys to successful installation to a self-leveler are selecting the right leveler for the flooring system and the traffic that you're going to be exposing it to. Properly analyze and prepare the substrate. Apply the appropriate primer, following all the instructions given to you on the technical data sheet of the packaging. Mix everything according to the instructions and protect from the environmental impact until it's fully cured. So if you follow all that stuff, hopefully you're going to be dealing with smooth sailing on the installation, on your next installation of self-leveling underlayments. And with that, I will turn the reins back over to Jen Kramer and open up the floor for any questions that might exist.
Actually, there were a few questions, but we have exceeded our time limit. So
Okay.
We will answer the questions via email. And thank everybody very kindly for their time today for joining us. And thank you, Jeff. That was a really great presentation. And this will be posted on our webinar page on our website as well. So again, we will answer the questions via email. And thank you again, everybody. And thank you, Jeff. And we'll see everybody next time. Have a great rest of your day.
All right. Thanks, everybody.
Thank you. Bye-bye.